to Unit 0, Lesson 6, Skill number 2, Proportions and Solving Applications. We just did ratios and rates. Remember, rates are special types of ratios. Proportions are also types of ratios. In fact, there are two rates stuck side by side. So proportions are equations that state two ratios are equal. Each ratio compares the same two units in the same type of situation. Okay, proportions can be solved for unknowns or proven to be true with cross multiplication. You can also use how we reduced fractions as well. If you just reduce fractions and they're whole numbers, it's easy to work with. But if they're not whole numbers, then cross multiplication is really easier. So let's look at these. Example number 1, Juanita had 2 different size containers of lemonade. She wanted to compare the number of ounces in each container to the number of servings of lemonade that can be made from each container. So which one does she want to buy? One container has 40 ounces with 10 servings, and the other is 84 ounces serving 21. So let's put them in a proportion. We have the 40 ounces gives you 10 servings. Put that information together. That's one container, right? Equals the 84 ounces versus 21 servings. So cross multiplication is probably the easy way to go with that one. So that is 40 times 21 is 840, and 10 times 84 turned out to be the same exact number. So they are the same, so they are a true proportion. So it actually doesn't matter which one. Neither one's cheaper than the other one, so she can decide just by the number of servings she needs as to which one to buy. Okay. Sometimes your book shows you to keep the ounces together and the servings together. You can do that. It comes out the same way to prove they're the same. Sometimes it also asks you which is the larger or better deal. I don't know. I kind of like that one better. It keeps, one container and then the other container. It just seems to work better for me, but whichever one. There are several ways you can do that. For some other people, it's much easier to just do ounces over ounces. And as long as you're cross multiplying, it'll work out. Okay, so let's try this one. An office has 3 printers. I guess I just like to start writing. 3 printers. Let me get this a little finer. And versus 18 computers. And the other one has 20 printers. If you're doing it the way I'm doing it, make sure you have printers on top. That's what you decided to do on this side. So printers got to be on top on this side. And computers are underneath here. Okay, so I find it helpful to write the units in, printers and computers. That way we have context, okay? And it says, is the ratio of printers to computers the same in these 2 offices? So if people are complaining they have, more printers than we have, that kind of thing. Let's see, it'd just be 3 times 105 equals 315, and 18 times 20 equals 360. And it just asks if they're the same, and you can just clearly say no. Okay. If they wanted more information, the way this is set up, you could come up with, they have 1 printer for every 6 computers, and this one here, if you reduce that, let me get my calculator. If you reduce that, right, they both can be divided by 5, so this would be 4 over 21. Sometimes you can put it in a decimal. 1 divided by 6 is 0.16. Repeating 4 divided by 21 is 1.19. So actually, these people do look like they have a few more printers, proportion-wise, ratio-wise. Okay? But this question just said yes or no. And they're not, since these are not the same, it's a no. All right, imagine you want to enlarge a 5x8 long photo and you want to turn it into a width that's got 10 inches and can keep the portions the same. So 5 wide over 8 long, and they want you to change it to 10 wide. And how long does this need to be a true proportion? In other words, to be equal. Personally, this is where I was talking about the fractions. If you multiply 5 times 2, you get 10, or divide 10 by 5, you get 2. Right? And so that means if I multiply this by 2, I get x equals 16. You can also cross multiply 5x equals 80. Divide by 5, and you get x equals 16. So however you want to think about that, 16 is the length you need to have equivalent fractions. Proportions are equivalent fractions. True proportions are equivalent fractions. So that'd be the same as 5 over 8 equals what over, with 10 over x. So this is where I get the times 2 times 2. So that's 10, and this is 16. Okay. All right, that was proportions. Now we want to talk about the metric system. The system that we have in the United States is the customary unit system, and the rest of the world has the metric system. Okay. And we're going to talk about lengths, weights and masses, and volume versus capacity. The metric system is something you don't have to memorize for this class, but we want to expose you to it to show some things you may or may not already know about it, okay? Especially if you're going into the medical, scientific, and technical fields, the metric system is used often, okay? And the U.S. system is based, is kind of a memorizing thing. They have a lot of strange numbers and units, but the metric system is based on a very simple base 10 system. It's a little easier to follow. And this means that each successive unit of 10 times is 10 times larger than the previous one, okay? So they go in a row by their size, okay? The names of the metric units are formed by adding the prefix to the base unit. So if we're talking meters, we're talking decameters, hectometers, decimeters, millimeters is the most common one you hear, but the base unit is meter, and by the word portion of the word in front of the word, the base word is telling you bigger or smaller, how many, that kind of thing, okay? So the prefix is what you're looking at to figure out what you're doing. So there's a mnemonic for remembering the prefixes. You don't have to. I promise not to ask you. It's just something people start to use. If you're in nursing, you may have to memorize this. But for this class, you don't. So in the base unit for meter is a measure in the metric system for length. So kilometer, hectometer, decameter. King Henry died. All the D's, all the H's, all the K's for no matter what the base is, right? This is these are also D's, C's, and, there's a typo, sorry. That's supposed to be centi. And M's, okay? So King Henry died drinking chocolate milk is the order from big to small. Okay. So all right, that's just some information about that. Okay, so let's look at that in detail a little bit more. We have units of weight, how heavy or light an object is due to its mass or gravitational influences on it. When measuring items on the Earth alone, weight and mass are fairly interchangeable. Okay? It's kind of like how much more do you weigh or less do you weigh on the moon because of the gravitational forces of the moon, blah, blah, blah. Okay, so When you're on the earth, the customary units we use is ounces, pounds, and tons. And for example, an ounce is about 28 paper clips. In the metric system, the closest thing to an ounce is a gram, and that's actually the weight of, or the mass of, one paper clip. Okay, so grams are quite a bit smaller than ounces. Everybody's heard of quarter pounders. The closest thing I have is a kilogram in the metric system. That's about 9 hamburgers. Okay, there's not a lot of match. We also use tons, and I didn't really find anything close to that. So that's weight. Then we have units of length. Length is a distance from one of the object to the other. Obviously, tape measure how long is something. US has inches, feet, yards, miles. Inches, the closest thing I have, about 1/25 of an inch is a millimeter. A little less than a half an inch is a centimeter. About 3 inches longer than a yard is a meter. And a kilometer is a little more than 1.5 miles. It's just a good kind of reference in general, okay? Again, not going to ask you that, just trying to let you know. Frequently things like, we know yards, but soccer fields in Europe are measured in meters, so it's just a point. The volume is the space taken up by the object itself, while capacity refers to the amount of substance like liquid or gas that the container can hold. So volume isn't the same as capacity. It's kind of, there's more to it. It's kind of what the metric system is built on is a volume, versus we tend to talk about what it holds. So obviously cups, pints, quarts, gallons. A milliliter is about 1/30 of an ounce. A cup is about 1/4 of a liter. A liter is a little more than a quart. Okay, so just some references there. What we want to know is how to convert from one thing to the other. Okay, one unit to the other. You will not be asked to memorize any units. Okay, so you should be given a conversion factor all the time. If you don't know it, ask. Some of your problems may not actually have the conversion in front of you, so feel free to look it up and then come back to the problem and convert. Okay, there are some conversions in the textbook that are attached right now to this course, so you can try those if you're missing a conversion. So conversion factor, let's start with an easy one. 1 foot equals 12 inches. How many inches are in 3.5 feet? So there are several ways to do this problem. I want to show you one that one way is to put the given information from out of the problem, put it over a 1, okay? And then times, you can put a dot there if you want, the conversion in the proper order. So if we're going from feet to inches, I need to get rid of the feet. So if feet is here, I want to put feet down here so it can cross out, and what I'm left with is inches. So 3.5 times 12 is 42. I think people have a little bit of trouble with that. Remember, this is why we learned how to multiply fractions. You have this fraction times this fraction, and you go across the top and you have 42 over 1. Sometimes when we do conversions, there'll be numbers down at the bottom in the denominator, so we want to make sure that we're multiplying fractions the proper way. Okay, and if you set them up focusing on the units first, it'll be quite easy. So this one gives you inches, which I wrote right here, and they want to know how many feet. So again, this is the given. That's how I refer to it anyway. And this is the conversion factor that they give you. All right. Now they gave me inches, so I want inches to be at the bottom so it can be reduced away. So I'm left with feet, but this is 154 divided by 12, which is 13 feet. Okay, that's how I do these. All right, and we'll put the practice on the next video.